There's a lot to take in here. So to start, let's just make sure you understand what's going on. We've got a picture, and each dimension of that picture is reduced by 20%, creating a smaller picture. And then that smaller picture, it has its dimensions reduced by 15%, creating an even smaller picture. That is what's being described in the problem. Now, there are a lot of ways we could go about solving this problem, but to me, the easiest strategy is going to be to pick numbers. Anytime your problem has no real values, no concrete numbers whatsoever, choosing numbers makes the math much easier. And here, because we're working with percents, I'm going to choose 100 because 100 is really easy to work with when you work with percents. So to start, let's imagine that the original picture has dimensions of 100 by 100. If we reduce each of those dimensions by 20%, well, what is 20% of 100? It's 20. In other words, the new dimensions would be 80 by 80. Now, as a next step, we have to reduce these dimensions by 15%. And remember, the way to get 15% of a number, get 10% and then get 5%. Well, 10% of 80 is 8. 5% should be half of that, or 4. In other words, to reduce the 80 by 80 by 15%, we're going to remove 12 from each dimension, leaving us with dimensions of 68 by 68. Now, the question here is to compare each dimension of this new second smaller version to the corresponding dimension of the original picture. Well, as we saw, the dimensions of this new second smaller picture were 68 by 68, and the dimensions of the original picture were 100 by 100. In other words, each dimension of this new second smaller picture is 68% of the original, because when we compare 68 to 100, that's 68 over 100, which is 68%. And there you go, that's the reason here that 68% is the correct answer.